So welcome, and we are already discussing about decisions for the development of a network in our supply chain environment, and we discussed in our last session a very conventional type of distribution network. You have distribution centers of the vendor, then you have a complete setup of manufacturing, and you have a warehouse within the plant, then you have distribution centers of the finished goods owned by the organization itself, then you have customer distribution centers and the customer stores, and there was a very serial network between all these facilities was there. Nowadays, if you see the changes which are taking place over a period of time in the supply chain systems, particularly with respect to development of facilities and their roles, the current slide gives you an idea that in our latest systems we have, in a global kind of supply chain environment, you have one finished goods distribution center at the national level. So this is a central facility within a particular country. Then you have various regional finished goods distribution center. So maybe if you take an example of India, so within central India somewhere, maybe around Nagpur, Bhopal, in that area, you have a national finished goods distribution center. And then if you divide India in 4 major regions, north, east, west and south, so for that you have 4 regional distribution centers, goods distribution center, finished goods distribution center, and then you have local distribution centers in maybe state wise. You can think of that you have one in UP, one in MP, one in Maharashtra, one in Gujarat, one in Tamil Nadu, one in Kerala, like that. And here you see these distribution centers are working on the principle of cross docking. We have already discussed in detail in our earlier sessions that what is the meaning of cross dock. The meaning of cross dock, just to give you a fresh idea, that where we do not keep physical inventory. These inventories are coming either directly from the national finished goods center or from the regional centers, and these inventories are just repackaged, redistributed at the local distribution centers which are working on the principle of cross docking, and then from these local distribution centers these products are going to customer distribution center or directly to the customer store. So you are either using one level of distribution from this point to this point, where you involve this customer distribution center, or you can do direct distribution from this point to this point, where you are bypassing, you are not using the customer distribution centers, and directly these products are coming from this cross docking location to the customer stores. So these are the changes which are taking place in our modern supply chain network, which are working on the multi-echelon finished goods network. So these are multi-echelon. Even you can say in our earlier case you have only one finished goods facility, 1, 2, 3, all these finished goods facilities were known as simply finished goods of the company side. But nowadays, instead of having a single finished goods facility, you are having 1, 2 and 3 installations for the finished good at the company side. So therefore, this term multi-echelon has evolved, and multi-echelon finished good inventory is coming. Before that, whatever we have discussed, that before this national finished goods distribution center, you have the factory where you are having a warehouse within the plant, and before that on the left side of that you have various vendor distribution centers. So that system is already there, but in this finished goods side, the right hand side of the supply chain, we have now developed a multi-echelon system by these 3 stages which we have included in the distribution system of the products. The very point, why should we have a multi-echelon finished goods network. I give this question to you that you need to think a lot, that why do we have earlier in the conventional system we were happy with a single type of, if you see that we were having simply this finished goods distribution center. We were not naming this as a national, regional or local finished goods distribution center. And now this finished goods distribution center are now changing into national facilities, regional facilities and local facilities. And then this is the customer side, which is already were there in the conventional distribution network also. So these changes are taking place because we want to fulfill the customer's requirement with minimum possible time. So if we are serving a country like India with one single distribution center, finished goods distribution center, the response time will be very high. So therefore, we want to reach to very close and even maintain that economies of scale, and therefore with national we are going to regional and we are going finally to the local distribution center. So this is a type of arrangement we are following in modern supply chain network. Now as discussed in the previous session, now we will discuss some of the methods for developing the location of these facilities. We discussing that we need to have three particular aspects. One is related to role of the facilities, the second is related to size, and third is related to location, where to locate the facility. And now for answering this particular question, we have some of the common methods, and I request all my participants that they should learn the uses of Excel, and we will solve this model with the help of Excel, and we will see that how this model is being solved. So the issue of location can be handled by this gravity method. It is a very simple method. Like gravity method is, to give you the background of the method, if we have this space where we want to locate our facilities, and now these are the probable sites, these are the probable sites where we can locate our facilities. So and these are the locations of my customers. So in the gravity method, with respect to all these sites which are represented by circles, I will calculate the cost for moving, cost of logistics from facilities to my different customers. Now whichever facility, whichever location gives me the minimum cost, that will become my answer, that will become my answer. So that we will discuss in this gravity method for location. Now before that, one more issue we will like to answer, that is the role of the facilities. Role we discussed can be of three types: manufacturing, warehouses and retail. But there is one more way to look for the roles. That role is what type of strategic advantage you want to have, and this strategic advantage can be with respect to the type of role you expect from your facility. Now the strategic advantage can be with respect to defensive or offensive. Now what do we mean by defensive role and offensive role in case of a supply chain distribution network? Now defensive role is that role where I want to develop a supply chain based on conventional thoughts which we just discussed in the last session, that this type of conventional network is there and I want to use the same network for my product also. So that is the defensive thoughts, and I just want to reach to the maximum possible customer as per my supply chain strategy, and I do not want to experiment. The point which is important, I do not want to experiment in the case of my defensive approach, in my defensive role of facilities. So whatever my competitors are using, whatever type of distribution network my competitors are using, I will also go with the same type of distribution network in a defensive supply chain system. In case of offensive supply chain system, now it is a different ball game. I will not go with this conventional type of distribution network. I will not go with this type of routine finished goods distribution center, routine customer distribution center, routine customer stores, etc. I want to use my network for some kind of advantage, and that is the offensive strategy of the distribution. And in that case, I may use some very innovative locations so that I can get the strategic advantage. My other competitors are using A type of market for distributing the product, but I will use B type of market for distributing the product. So it is a very different type. It is always not sure that offensive type of approach will give you success, but at least you are not going on the conventional way of distributing the product. That is the idea behind this offensive distribution system. The conventional distribution system gives you the defensive approach. Competitors are doing that way, I will also do that way, so that I will at least match my competitors' performance. Offensive can take you much above to your competitors, or maybe you may be at least totally lost. So offensive strategy is a kind of innovative strategy in case of distribution, where you are expecting that your facilities will have a role which can provide you strategic advantage, that is by the offensive way of distribution. In our literature, you will see sometime when a manufacturer, when a supply chain manager decides for a offensive type of strategy, and if it becomes successful, then all other competitors will start following the same strategy, and over a period of time that offensive strategy will become defensive strategy. So you have examples where you started using ATMs. So ATM once upon a time was part of offensive strategy, because normally you go to a bank, the physical branch of the bank, and to withdraw or to deposit your money. But when ATM started coming, so you can go to a ATM at any time to withdraw your money, and then later on to deposit your money also. So this became an example of offensive distribution. But over a period of time, now it is almost impossible to think any bank without ATMs. So now ATM is a very much part of defensive distribution system of the banking products. So all success, initially we started with some e-portals in India for e-commerce. At that time customers were hesitant whether this e-commerce, e-portals will be successful or not. But over a period of time, now we see almost every company. So initially it was offensive distribution. We were very comfortable with brick and mortar distribution system. You need to open a showroom, you need to open a shop, etc. But this type of distribution using electronic mode was almost new for us, and products like shoes, sweaters, jackets, mobile phones, laptops, all coming through this electronic mode of distribution. So it was initially the offensive way of distribution, but nowadays it is almost impossible for a company to survive without this E mode of distribution, electronic mode of distribution. Therefore, it is very necessary that for initial advantage, you think on the basis of offensive way of distribution, and later on it can become a defensive way of distribution. But we also have one example where offensive way of distribution did not lead to defensive way of distribution. You may be knowing a name of company known as 3M. 3M is a very popular name and which is world leader in the market of adhesives. Now 3M once upon a time launched a product known as phenyl. Phenyl, we all know, is used for cleaning your floors, etc. And phenyl, normally we all know, is available through hardware shops, is available through general stores, maybe in some cases medical stores also. So these are the places normally we all know, or the shopping malls also. These are the places normally where you get the phenyl as a product. But 3M, because they were thinking of offensive way of distribution, so 3M used a very different way of distributing the product. 3M thought that let us use beauty parlors for distributing this phenyl. Now the beauty parlor for distributing the phenyl is never seen before that. So 3M used these beauty parlors. Now in the case of beauty parlor, the idea was that normally phenyl for the cleaning purpose is used by females in the families, and females visit beauty parlors, and they wanted to promote their product as it is safe for skin, it is safe for nails, it is safe for nail polish, etc., etc. So they thought that let us promote, let us position this product as a beauty product for the cleaning purpose. But unfortunately, this distribution idea of using the beauty parlors, beauty shops for distribution of phenyl didn't work. The reason is also very simple. I think we all can understand that those who are visiting beauty parlors are not using phenyl for their household purposes. They can afford maid, etc., and those maid do not visit the beauty parlor. So the idea didn't click finally, but it became a very classic example in literature that how to think of offensive way of distribution where you have totally innovative idea of distribution. So this is with respect to role of distribution facilities. Now another important area is location. So we are now going to discuss the area that is gravity method of location to decide about the location, how to decide that which facility, which site should be selected. Now for that purpose, the model which we are going to use can be this type of model where you have x and y, the coordinates of the warehouse. So these are the coordinates of these type of facilities which are the warehouses. So I want to locate the location of my warehouse. So these are represented by xy. Then these xn and yn, these are the coordinates of delivery locations n. So if I see on a graphical axis, so this is x, this is y, so these are my delivery locations. The coordinates of these delivery locations are x and yn, and I have to select a site for my warehouse. The coordinates of this are xy, and dn is the distance to delivery location n. So dn is the distance of this warehouse site to this place. This is dn. So for all these delivery locations, I can have dn with respect to that. And fn is the annual load which I want to deliver to a particular deliver location n. So that is the load with respect to a particular delivery location. Now, this is the formula for dn, x, that is this, minus xn, this is, plus y minus yn, and the square of these two terms, the under root will determine the distance of this distance is this minus this location, x minus xn to whole square plus y minus yn whole square, the under root. So, that is the formula for calculation of dn. Now, I want to determine actually the coordinates of my warehouse x and y, and for that purpose I will see that how I will determine. So, this is the formula for determining the location of x and y. Here you see this is dn, xn, fn. dn is the distance, xn is the coordinate of the warehouse, this delivery location, and fn is the total load which I am going to deliver to that, divided by this distance, and this is the sigma term, and same is for the y. So, this is how I will determine the coordinates of x and y. Now, once I determine this x and y, then with the help of this example you can come that how can we use for the purpose of determining the location of our warehouse. We have these different sources and these are the markets. So, I have to take a decision where to establish my source facility. So, these are Pune, Gurgaon and Jamshedpur. These three areas are the sourcing facility. This is for some kind of automobile problem, and the markets are available in Ahmedabad, Cochin, Hyderabad, Chennai and Bangalore. The transportation cost, that is rupees per ton per kilometer, is 90, 95, 85 from these supply sources and to these different market sources. Now, quantity in tons from the supply sources are available 400, 200 and 600, and in the demand for the different markets are, this is the data. Now, on this graphical source, the coordinates of supply sources can be 700,000. So, if I see this is if I want to have India on this map, so the coordinates of Pune, coordinates of Gurgaon, coordinates of Jamshedpur. So, you can get the idea of the coordinates here. So, now we will go to the calculation, the model which we just discussed. This is how now you can also start using the Excel on your computers, and this is how we will develop the input data for our gravity location model. You can use almost the same table. This is the portion of that table spreadsheet which I will like to show you, that from column B to column F. This is how you will input the data. These are the supply sources, these are the markets. You also please try simultaneously with me. Pune, Gurgaon, Jamshedpur, Ahmedabad, Cochin, Hyderabad, Chennai, Bangalore. So, you use this data, the transportation cost data, quantity which are available at these places and which are required at these places. This is the source, these are the destinations and the coordinates. So, this is the input data. In fact, this is exactly the last table which was given to us in the simple format, and I have just copied the same table in this Excel spreadsheet, and I think you also start using from B to F and from row number 2 to 11, so that you can follow while doing the calculation at your end with the help of formulas which we will be developing, and you can see that how these results are coming there. Now, for that purpose, the formula which we need to use you see this is the this much spreadsheet from B2 to B11 we already have, this much spreadsheet we already have. Now we need to develop some formula which we will build in this spreadsheet, and what will be those formula that we can see here in cell number G4. So which is that G4? G4 is this cell. G4 is this cell, and in this we want to determine this distance dn. We want to determine this distance dn. So we will build the formula for dn here, and the formula for dn, as you know, x minus xn to the whole square plus y minus yn to the whole square, the whole under root. So that formula is written this cell, and that is square root of B15 minus E4. B15, this is B15 minus E4, this is B15 and E4. This is the final coordination of the facility we want to locate, x. This is the xn, so x minus xn to the whole square plus B16 minus F4 this. So B16 minus F4 to the whole square. So this is the symbol for square, and the under root, the square root of this whole bracket. So what we have written in that algebraic form, the same is written here in the form of Excel formula builder. So square root double brackets B15 minus E4, E4 I am giving as absolute value, and B15 the dollar symbol here, these are for the relativity, because as I am moving from this 4th row to 5th, 6th, 7th, 8th, 9th, 10th, 11th, I need to change the values of xn. The values of x and y are constant. These are B15 and B16. So I need not to change these values, but I need to change E values, E4 and F4. So E4 and F4 will change, and B15 and B16 will not change because of this dollar symbol. So these are fixed, and then I will copy this formula which I will be developing initially for G4. I will be copying this formula from G4 to G11. So I will copy this formula from G4 to G11. So for this entire column I have copied the same formula. So when I am copied the same formula with this type of equation, so in each of these cells B15 and B16 will remain common, and E4 and F4, E4 will become here E5, here it will become E6, E7 and so on, here it will become E11. F4 will become F5, F6 and F11 in each of these respective cells. So my formula will change as per the different values of cells. And since the initial values of x and y I have kept 0, 0, so these are the calculated values with the help of that formula. Now coming to second formula, that is for cell number B18. In B18 we are putting the total cost. We are putting the total cost. So total cost, as you know, is the sum product of these three values. If you remember the formula which we discussed in the slide of initial slide of gravitational model, so this formula where you have multiplication of G4, D4, C4, G4 this value, D4 is the total supply available, G4, D4 and C4. So this is the transportation cost. So C4, D4, G4. So this is one product. Similarly, C5, D5 and G5, this is another product, and so on. You will have up to C11, D11 and G11. The sum product of all these is written like this. In Excel, it is written like that: from G4 to G11, we will like to multiply D4 to D11 and also C4 to C11. So G4 will be multiplied with D4, will be multiplied with the C4. G5 with D5 with C5, and so on, G11 with D11 and C11, and the sum product of that is coming in the B18 column, B18 cell. So this is the value here. This is the value here with the help of this. Now I want to optimize, and for that purpose I will use this cell. This spreadsheet portion is getting after we have the location of x and y. If I go with this data, the location of x and y is at the center, at the origin, because x and y is given 0, 0. Now my job is to reduce this total cost as much as possible, and for that purpose I will invoke the solver, and solver will say that if you invoke the solver, so this type of solver parameter will come, this type of dialog box will come, and here my target cell is B18. This you will write here B18. So this will be your target cell. I want to minimize this, so equal to these options will come. So I will select this box, minimize. In some cases we will go for the maximize also, but here we want to minimize the total cost, so we will go for the minimum value of the total cost. Now minimum value of total cost will be achieved by changing the values of B15 and B16. So by changing the cell, these are the decision variables. If you have the knowledge of linear programming, so we can say that B15 and B16 represent my decision variables. So these are the changing cells, and with the help of this, now I will start solving this, and once we start solving this, the values will be 700 and 1500 approximately, because once you have done this, then you put the cursor on the solve, click this button, and this solver will give you this type of optimized result, where now you see your values of all these 1220, 538, 854 are changed. These are 500, 11, 18, 806 and so on, and now the values of x and y are 700 and 1500. Values of x and y are 700 and 1500, and the total transportation cost is now reduced tremendously from this value, which was 477,873,268. Now it is 193,549,144, and the location of warehouse is 700 and 1500. So you can see this 700, 1500 is very close to this Hyderabad. 700, 1500 is almost Hyderabad. So you will decide that the warehouse should be at Hyderabad. So we are stopping at this point, and we'll see further that what other models are available for getting our optimized location of the facility. Thank you very much.